But you can use whatever method you want on either section. So if you end up liking what we do today, the way I do it today, and the second method I show you today, and you want to finish up your 2.5 homework using that method, that's fine. If you are really comfortable with that 2.5 method and a few algebraic manipulations to put it into that form, then you can do the 2.4 homework that way as well. In the long run, I know mathematically you need to understand that 2.5 method. That's why I taught it first. That's why I'll be mentioning it again as we go through this. But in terms of just pure algebraic manipulation, maybe is a safe way to get them right now. The 2.4 method might be the way that some of you want to go. I'll even show you for a couple problems a third method that I don't like at all, but that works really well. You just have to understand what's a little bit wishy-washy about it. Yes, sir?
Are we going to need to know both of these for the test?
On the test, you can use any method you want to solve problems. Okay, you won't have your calculator up, so you can't just hit solve in the calculator.
I don't even know how to do that yet.
Yeah. You need to learn. You need to learn incredible power. Solve, hit the equation, comma x, it solves it. Okay? It involves complex numbers. You don't even know about those yet. You put a c in front of it. If you want to get a numerical approximation, put an n in front of it. It's unbelievable. All right. So here we go. You can start the video. And we're going to talk about this. Maybe I already did.
Yeah.
No problem. Okay. That when you look at these videos, I know a few people are starting to do that. You can just fast forward right through. You can just move it up. All right. You need to know that this is true. Okay. The absolute value of x, we can think of it as the distance from x to 0 on the real number line. But there's another way to think about it. It's as what's called a piecewise defined function. Piecewise defined. Defined in pieces. And we think of it the following way. The absolute value of x is x itself if that x value was greater than or equal to 0. If I ask you what the absolute value of 11 is, you say 11. Absolute value of 0, you say 0. The absolute value of 12, you say 12. But if I say absolute value of negative 4, you say 4. If I say absolute value of negative 1.2, you say 1.2. So if my x value is less than 0, the absolute value of x isn't x. It's what? What's the absolute value of negative 7?
7.
So it's not negative 7, it's the opposite of negative 7. It's the opposite of x. And if you understand this well, it gives you another way to do these kind of problems that we've been solving. With a good understanding of what absolute value means. That if you're dealing with a positive amount, you leave it alone. If you're dealing with a negative amount, you take its opposite. That's what that's saying with math symbology. If it's not negative, leave it alone. If it's negative, take its opposite. That's how absolute value works. So we go to this first set of 3 problems. We have the absolute value of x is 5. Problem B, the absolute value of x is less than 5. Problem C, the absolute value of x is greater than or equal to 5. And in this class yesterday, in this section, I told you that if you can isolate the absolute value on the left-hand side, you have a positive number on the right-hand side, that when you have an equals, you're going to always end up with 2 numbers. When you have a less than, it's always going to be between, a between case, an and case. When you have a greater than, it's going to be the outside. But let's see if we can understand why that is. If the absolute value of x is 5, well, what numbers work? What can I stick underneath my fingers here so it would work? The absolute value of what numbers are 5? Anybody say? 5? Negative 5. So we just think about it. We say, therefore, x is negative 5, or x is 5, and there's our graph. It matches it.
Do you fill in the circle?
It should be filled in. It's just a filled in circle, only that, nothing else. Okay, it didn't look like it was, but it should have been. Now, what numbers could go underneath my three fingers here? I could put 3 in there, or 4.8, or 4.97, or 0, or 1. I could put -2 in there, -4, -4.5. I have to put numbers that are between -5 and 5, right? They have to be between -5 and 5. So since the absolute value of the number is less than 5, that number is trapped between -5 and 5. There's the graph. In this case, the absolute value of something is greater than or equal to 5, so it could be 10, it could be 1,000 or a billion, but it could be -7 or -8. And what it has to be is for the absolute value of something to be greater than or equal to 5, the something's got to be less than or equal to -5, or the something's got to be greater than or equal to 5 itself. There's the -5, there's the 5. That's the three forms of the problem. Granted, we might have less than or equal, greater than equal, greater than. Yeah.
It should be filled in for the third one, right?
Yes, thank you. It's supposed to be, and since I wrote it with greater than or equal, it's supposed to be equal. So thank you, Michelle. Correct now. And we probably should put arrows on there as well. If I was labeling, doing super serious work, I'd label this as the X number line. These are the X's that work. These are the X's that work. Okay? So anybody have a question on those three problems? Okay, so I'm going to do three more problems very similar. Okay? Assume this C is greater than 0. So I have the absolute value of X equals C. The absolute value of X is less than or equal to C. The absolute value of X is greater than C. Now I'm just going to go down rows today, take a little pressure off. So Harrison right here. C's a positive number. I want to solve this. What could X be?
C or -C.
X is -C or X is C. Now Harrison said C or -C. I said -C or C. Same thing. The reason I went -C or C is because it's the number line order, but it's not even necessary. What he said is totally fine. Excellent job. It works. We're trying to figure out numbers that work. We need numbers whose absolute value are C. Well, C, the absolute value of C, since it's positive, is C. But the opposite of C would also get a C as well. That's it. Jordan, the middle one. What numbers work? What could X be if the absolute value of it is less than or equal to C?
Anything less than or equal to C.
No, not anything. Because, like in this case, anything less than 5 didn't work because -8 didn't work. The absolute value of -8 is 8. It's not less than 5.
Well, it has to be within C, but I don't know if C.
Okay, it has to be, if this is C this way, what's this direction?
-C.
Right, it's got to be between -C and C. Because we assumed C was positive. So it had to be between the C value and the opposite of that C value. So that's how we say -C is less than or equal to X is less than or equal to C. And Lee, how about on this one, if the absolute value of X is greater than this positive number C?
X is less than -C, or X is greater than C.
Perfect. And the graphs for this are going to be very easy because I'm just gonna put a number line right below, and I'm going to put it can equal this number, it can equal this number. We're calling that C. We're calling that -C. Right here, same thing. Put the -C. Put the C. X is between it. Inclusive. Let me not make the mistake again. It says equals, so this has to be filled in. Here, number line C, -C, X is less than -C, or X is greater than C. Those are the three possibilities. Those are the three possibilities. Again, this could be greater than or equal, make a fourth possibility. This could be just less than, that's a fifth if you want. But basically, three different forms that we get on that. Okay? All right. So Ava, make sure you get that on the camera. It's not there. or leave it there for a second, and we're gonna go over to 3 more problems. I'll write it down, and we'll come over. The next problems. Now, what I taught you yesterday, we could do these problems. I haven't. But we could have. Like these problems, I could think of this as the distance from x to 0. The distance from x to 0 is greater than equal to 5. And so think about 0 comes by both ways. It's the same as what we did before. Here's the 0, there's 5, here's 5. If the distance from x, think of that as x minus 0. The way we did yesterday would have worked, right? Okay, but we haven't been doing that today. We've just been talking about a different way. So these problems are not real clean. They're not in the form where you look at them and you're thinking, oh, I'm going to erase this. But it's not in this form where it's the distance from A to B. This one's pretty close. That one was a little bit of work we're doing. This one we could put minus 0 and then multiply by a third and do it. But they're not in that form directly, so you might be more comfortable using this new approach. Okay? So, Jay, I think it's your turn. Okay?